Hello everybody, this is Mrs. Steiner. Welcome to my kitchen. And I'm going to do an input chart on how thermometers work. So first thing I'm going to give you a title. And this is just letting everybody know I am not an artist. So how do I'm an artist and I'm not a great speller. So what I'm going to do first, I got to put my glasses on because I can't see, is I'm going to draw a thermometer. You've watched this video already on how thermometers work, and I thought I would sort of explain what they're talking about. So here is my thermometer. And like that. Some of you may have thermometers at home that are round. This is just kind of colors or something like that. And a lot of them, they have numbers. They may have a Fahrenheit scale on one side, Celsius on one side, and then they'll have numbers. I won't fill in all the numbers, I'll just put the lines in. Like this. And inside this thing, they have a fluid. It's changed over the years. They used to put mercury in it, but they don't anymore. I've got the fluids inside of this. Is my thermometer. So if you were to go outside today and you would ask yourself, what's the temperature today? So, or how warm is it? How hot is it outside? How hot? So you would probably look at your thermometer. So when you say how hot it is, or you could say, what is the temperature? You could also be asking is how much heat energy is outside. It's kind of the same thing. That's what temperature is. How much heat energy? I'm not sure if you could see it. I'll show it to you when I'm done. So how much heat energy is outside? So when we're talking about is we're talking about the temperature is actually the average measure of the kinetic energy of the particles outside. So I'll add that in here. Temperature is the measure of average kinetic energy. Did I spell that right? And it's Y of particles outside. Okay, so everything's made of particles. Even we've got particles outside floating around. That's our heat. So each of them have a kinetic energy, which means these particles are moving. The warmer we get, the more the particle moves. So we also know, as you probably learned from the videos, that heat or heat transfers, heat is the actual energy. Heat is the heat energy. Heat is equal to amount of heat energy. Oops. That's an H, heat energy. So we're talking about, when we talk about the temperature is the number of the amount of kinetic energy we have. Heat is actually it's energy. That's all that heat is. So heat likes to transfer. Heat always transfers from high to low. So I mean, you've probably heard of that before. Heat will rise to the top, smoke rise to the top. So heat always transfers from high to low. So this is something right here you have to remember. In this unit, the heat always goes from high to low all the time. So inside here, when we're looking at my wonderful drawing here of my thermometer, inside here we've got molecules that are bouncing around. So if we're outside and it's a hot day, and I'm sure you're going to be able to guess, when it's a hot day, the heat from the environment outside where the thermometer is going to transfer into the thermometer because it's going from high. If the outside temperature is warmer than it is where the thermometer is sitting, so let's pretend that thermometer is outside. I take it in from my house to my apartment here and I go hang it outside. It's warmer outside. So that heat energy is going to go transfer to the molecules. So I've got higher heat energy transferring into my molecules. Here's my heat energy. And this is higher. So it's going from high to low. It's transferring into my thermometer. So as it transfers into my thermometer, the molecules inside there are like, whoa, here comes some more energy. So it's this, the things are bombarding the heat energy is going in, hitting these molecules. The molecules, in turn, the molecules in that fluid, start to move. They start to heat up too. So it wants to equalize. So it's going to be transferring heat. And the molecules in this fluid gain energy. When it gains energy, the molecules start to expand. It starts the liquid in there, the fluid in here, because the molecules are moving more, it starts to expand. Gain energy, and it starts to expand. It starts to expand, and as it expands, it's going up. So let's say it's 70 degrees outside, and say my fluid in here is, because I had it in my apartment, was only 68 degrees. I take it outside, and then the heat energy bombards this fluid. The molecules start speeding up. As they start speeding up, it starts to expand. All forms of matter will expand when it's heated. Metal, if you ever walked across a bridge, you notice it's got these expansion strips. The cement, everything in it, as it heats up in the day, will expand. And they need those expansion strips in the bridges so we don't end up breaking things. I read somewhere that the Eiffel Tower grows a certain portion every summer if it gets too hot. Of course, and they have to be able to be flexible so it can expand. So it will keep on. So as its molecules gaining energy, it starts to expand. This liquid in here will keep on going until it reaches what's called thermal equilibrium. We'll keep on expanding. Keeps expanding till it reaches thermal equilibrium. I don't have somebody across me tell me which ones I'm making spelling mistakes I'm making. So thermal equilibrium. Going to underline that. Everything wants to reach thermal equilibrium. So it wants to reach thermal equilibrium with the environment. Okay, so that means the air outside. So this is going to keep on going. If it's 75 degrees outside, it's going to keep going until this liquid, this fluid in here, reaches 75 degrees, and then it will stop expanding. So if the temperature were to rise even higher, it's still got heat energy going in, and it's causing this liquid in here, the molecules to get excited and start moving, and then it starts to expand. The particles start expanding. And then if the temperature goes down, you're gonna have to take a guess on that because that's one of the questions you're gonna have to answer. So thermal equilibrium, I have to move down a little bit far. Oh, you won't be able to see it. The advantage of not having a whiteboard. Okay, I'll fit here. Thermal, sorry my writing, equilibrium. I'll try to do my best to spell it correctly. I'm sure you guys can guess what that means. Thermal is, in other words, we're talking about heat. Equilibrium, we're talking about the same. Okay, you see that? Yep, so that's how we get, that's thermal heat equilibrium. So this wants to reach thermal equilibrium. We got things points you got to remember is heat always transfers from high to low. You have to remember thermal equilibrium. These molecules will keep going because it wants to reach thermal equilibrium. So the reason it transfers from high to low because it wants to reach this. It wants to reach thermal equilibrium. So this is basically a quick kind of input chart how thermometers work. I think I remembered everything. I've got a kind of a cheat sheet down here I'm looking at. It says can be transferred. So my question I have, the challenge question I have, what would be different in this input chart if it was outside was 25 below? So what would be different about this chart? I'm going to add it to your question, to your assignment. Is look at this chart. What would be different about this? So we'll talk to you later.